Solve for x.
Solution steps. Isolate the radical. The equation is already in a good form with the radical isolated. Square both sides. Rearrange the equation. Factor the quadratic. Set each factor to 0. There you have it. Radical equations can be applied in various real-world contexts. Here are a few examples. Physics of free fall. When an object is dropped from a height, the distance it falls can be modeled by the equation. D equals a half gt squared, where d is the distance fallen, g is the acceleration due to gravity, and t is the time in seconds. If you want to find the time it takes for an object to fall a certain distance, you can rearrange this equation to solve for t. T equals square root of 2d over g. This is a radical equation, and it helps in determining how long it takes for an object to hit the ground from a specific height. Construction of the area of a square. If you are designing a square garden and you know the area, you can use a radical equation to find the length of one side. The area A of a square is given by A equals S squared, where S is the length of a side. To find the side length when you know the area, you can use S equals square root of A. For example, if the area of the garden is 100 square feet, the side length would be S equals square root of 100 equals 10 feet. Finance, interest rates. In finance, the formula for compound interest can involve radical equations. For example, if you want to find out how long it will take for an investment to double at a certain interest rate, you can use the formula A equals P times 1R power T, where A is the amount of money accumulated after n years, including interest. P is the principal amount, the initial amount of money. R is the annual interest rate, and T is the time in years. If you rearrange this to solve for T, you may end up with a radical equation depending on the specific scenario. Engineering structural load. In engineering, the load capacity of a beam can be determined using formulas that involve square roots. For example, if the maximum load L a beam can support is related to its dimensions and material properties, you might have an equation like L equals K square root of B, where K is a constant and B is a dimension of the beam. To find the dimension needed to support a certain load, you would solve B equals L over K squared. Medicine, dosage calculations. In pharmacology, the dosage of medication can sometimes be calculated using formulas that involve square roots. For example, the body surface area BSA is often used to determine the appropriate dosage of certain medications. The Mosteller formula for BSA is BSA equals square root of height times weight over 3,600, where height is in centimeters and weight is in kilograms. This radical equation helps healthcare professionals calculate the correct dosage based on a patient's size. These examples illustrate how radical equations can be used in practical applications across various fields, including physics, construction, finance, engineering, and medicine.
Thank you for watching. Like, share and subscribe.